We have an airplane that's flying with the wind, takes 2 hours with a 25 miles per hour tailwind to reach its destination. Now the return trip takes 3 hours flying against the wind. What is the speed of the airplane in still air? Round answer to the nearest whole number. So we have our starting point and our ending point, okay? So the first trip, we can call this even trip 1. The plane is going here. Trip 2, the plane is just going back, okay? So notice one thing to consider here is that the distance is the same both ways. Now when I do these kinds of problems, I like to use a table. So I use distance equals rate times time, an equation you definitely should know. So make sure if you don't know that, put it on a note card so that you can learn it. And we're going to set up a table. So we have 2 trips with each direction the plane went. Now we've already talked about the distance being the same for each, and so we don't know the distance, and so we're just going to put D for distance for both of those. Now we have an airplane flying with the wind, takes 2 hours with a 25 mile per hour tailwind. We don't know how fast the plane is going, so we'll just call the rate of the plane R. But we know it has a tailwind, which is pushing it, making it faster. So we're going to have R plus that 25. And it tells us that took 2 hours. Now for the return trip, it takes 3 hours, and now it's flying against that same wind. And we'll still assume it's that 25 miles per hour wind. So this time we take the speed of the plane R, but now we have to subtract that 25 because it's slowing the plane down. And this time it took 3 hours. Now let's take a look at our table. Does it look like we set it up right? Does it make sense that we'd have a faster rate for less time and a slower rate would take more time? Well, yeah, if you think about that, if you're driving, if you go faster, you'll take less time to get there. If you go slower, you'll take more time to get there. So that looks good. So now what we'll do is we're just going to write out these equations just using this distance equals rate times time formula. So we have distance equals R plus 25 times T. Now very important, we need to put this in parentheses because T needs to be multiplied by the entire rate. So very important that that's in parentheses. We'll do the same thing for the bottom. D equals, again in parentheses, R minus 25 times 3. Let's simplify these. So here we're going to get D equals 2R plus 50. In the bottom one, we're going to get D equals 3R minus 75. Now there is a rule that says if A equals B and C equals B, what can we assume about A and C? Well, we can say then A equals C, okay? So if A equals B, C equals B, they both equal the same thing, then we know they equal each other. We can use that here. We know distance equals 2R plus 50. We know distance equals 3R minus 75. So now we can say 2R plus 50 equals 3R minus 75. So 2R plus 50 equals 3R minus 75. And let's go ahead and solve this. First, I'm going to get the variable terms on the same side. So subtract 2R from both sides. I'm left with a positive 50 equals R minus 75. You could say 1R, but I'll just put R. Solve for R by adding 75 to each side. Those cancel, so I end up with R equals 125. So that tells me the plane goes 125 miles per hour. So that's this plane speed. Now let's read the equation or the question, make sure we answered what we were supposed to. So what is the speed of the airplane in still air? Round answer to the nearest whole number. Well, we've done that right here. So that's our answer. If we needed to find the distance, maybe it had asked us to find the distance. How would we do that? Well, we could just take this rate and substitute it into one of these 2 equations and solve for D. So I really recommend using a table for this one. Let me know if you want help on this or want to just go over it with me.